let's start with this one. What are the main difference between those two, A and B? Yep.
Action oriented is B.
Yeah. Yes. Indeed. Yes.
Assumptions, facts.
Yes. It could also be a fact, but no, you're right. It is an assumption. So yes. This is something that we see every single day when we come to clients as part of their incident logging, as part of their problem logging. Basically, this is the same issue. So ongoing for 1 year, solved in 2 days. And the difference here was that 2 skilled supporters, they went in and they did a specification of this, separated, clarified what was it all about, and then took it bit by bit and solved it. So what we very often see is that problems become general, and you cannot solve problems in general, and there's a lot of waste of time in companies. So it was just an example of that. So some of the challenges within the incident problem resolution part is that we see a lot of in the IT in the IT domain, we see a lot of recurring incidents and problems that persist week after week. It is a young industry, but we also see this inefficient troubleshooting. And by inefficient troubleshooting, let me just give you some examples of that. We see a lot of resources that is wasted because the quality of the data that is put into incidents and problems are so poor. So we see that the technicians are working on stuff they don't know what they're working on. They have to contact again to get further clarification almost every single time. They work on assumptions. Sometimes the assumptions are wrong, so this could mislead them. So this really eats the resources for breakfast, and this is a key skill to be able to solve these issues. We see very reactive organizations, and we also experience a lot of companies, IT organizations, that are struggling with, they call it implementing, you really can't do that, I'll come back to that, but work with the problem management part, the preventive part, and they're really struggling with that. We see that Agile is coming in, DevOps is coming in. That requires even better troubleshooting capabilities because now we are deploying stuff all the time and stuff like that. So we really need to be good at this. So it's a key skill that everyone needs to be good at. But right now, the capability is not keeping up. We also have our brain, our protein computer that really want to jump to conclusion. That's a natural thing for our brain to do to save energy, to save the effort of starting doing some heavy analysis. So we have a really strong tendency to jump to conclusions. That's not really good if you are running critical IT services for any kind of business company. So that's what we are facing. The common solution for this in the IT world is looking at ITIL, or at least it has been for many, many years. I think ITIL is fantastic for what it was supposed to do, but the perception of what ITIL can do is misunderstood for many people. If we just look at the incident part, yeah, ITIL describes how this could look, what you could do. It's just a catalog of some ideas that could work someplace and maybe not. But it doesn't tell anyone how to solve it. So it's about how you manage incidents. It's how you move tickets around in your company. That's the only thing it states. So how you solve it, there's nothing in it. This is from the book. This is what there is about the quality of incident logging. So basically it's 0. And this is about investigation and diagnosis. There's nothing else in ITIL. So it will not help any organization getting better at troubleshooting. It works well for what is obvious, because what we have seen before, we can put into a service management system and we can speed it up. electrify it and then move these cases very fast through the system. So it works fantastic for all the simple stuff that we've seen before. It doesn't work for all the complicated and complex incidents and problems, stuff that we haven't seen before. It doesn't simply work. So just to take the problem part. So it's the same. So what about problem management? Yeah, problem management is about managing problem. Again, move tickets around in your system. There's nothing about how to solve them. This is what there is about investigation and diagnose, or could call it root cause analysis or whatever you want to call it. But this is what there is in all the books. So again, the same for the incident part. It will not help any organization. There are a lot of organizations that believe, now we will send people to an ITIL course and then they'll come back and then we will have a well-performing incident process. Maybe if the challenges are different from this, but if it's the resolution of this, and that is the main part of incident and problem, is how you solve it, then you won't get it from here. A paradox is that working with these high-level process descriptions, because this is not a process, this is process descriptions, working with these high-level process descriptions sometimes decrease the efficiency if the quality is not in it. And the same will happen with putting in service management systems. They will decrease the efficiency of an organization if the quality lacks. Because it's much easier to just send a case to another team, then it's not my responsibility anymore. The quality is crap, but I don't care. So now it's on your table, and you can decide what to do with this. So it's very easy to get rid of the responsibility when you have a service management system. And that leads me to the next slide. Service management systems. Sorry for ServiceNow. ServiceNow is a good tool, a very good tool for what it was designed to. But still, these tools, they support the management of tickets. There's also some knowledge part and stuff like that. I'll come back to that later on. But mainly, they support how to move the tickets around. So there's no help here whatsoever for solving complicated incidents and problems. Sorry for that. I don't know if you can see this. Most IT service management systems, they have a headline or short description, as it's called here, and a descriptions. Even here, you don't get any help at all. So I can't see if this is from a sausage company or a car manufacturing company or an IT organization when I look at their tool. It's just a generic tool that doesn't support the way of working. What kind of information should we gather? Where should we put it? How do we work with this? There's no help at all. It's just a system that can move the tickets. And if I go into the problem part, it looks very similar to this. Yes. So troubleshooting is a practical skill. It's a key skill that we all need to be good at. So for about 3 years ago, we made an analysis because we were running some traditional training in troubleshooting. It was Kepler Trigo courses, also within other methodologies. And people were very satisfied with these training courses, so the marks were very good. But when we talked to them after 3 to 6 months and asked them how much of this have you applied in your daily work, almost nothing has been applied. When we started to run the simulation part of this, I'll come back to that later, we always start with what we call a discovery exercise. That's the first thing we do. We do it within 15 or 20 minutes from the startup of any training. So we run them through something, an exercise, an incident or problem they need to solve, to show them how you do it today, what is your current status of how you solve this, and then we measure on that and measure them through the different scenarios. What you see up here is that the participants with there's marked with orange, they have not completed any previous course in troubleshooting, so they haven't been on any course at all. The blue, as you see up here, they have participated in some kind of course. And what we could see here is that when we run the discovery case, some of the teams doesn't solve anything, some solve it partly, and some solve it completely. But there's no difference, almost no difference in people that have attended a theory course, a traditional course with PowerPoints, probably some exciting games, some paper-based cases, some fantastic examples and war stories from the instructor, but there's no difference. They can't apply it. The distance, the gap between what they get on the course, on traditional training, and what they get back to in the real world is just, the gap is too big. So they don't apply basically any of this. So that was kind of worrying, and we started to discuss what we could do also before we got the simulation part included in this. So having a look at what do we do in other professions? Yeah, all of these professions have one thing in common. They are team-based and they are skill-based. So it's practical skills. And practical skills, you cannot learn a practical skill by reading or by watching PowerPoints or by hearing fancy examples or war stories from an instructor. It's simply not possible. So, oh, sorry. I'll just click here. So how do these professions improve their skills? They practice. That's the only way they can do it. So, yeah. This orchestra practice here, we have this, also some kind of simulation for the doctors. We have for pilots. Would you fly with them if they have skipped the simulator training? Probably not. If you knew it, then you'll probably select another plane. Yeah, and we have on the training ground, we have these football players. So we need to practice, we need to exercise, experiment, we need to feel the consequences of our actions if we want to learn something. I have clients that states, no, we practice every single day. So we have a lot of incidents. We have major incidents every single day. So we practice major incidents. So we don't need this. And the only thing I can say to that is, no, you do not practice. Because what you do in your daily work is not practice. You cannot try something when you have a major incident to see how it goes and see, let's try something new. No, that's not possible. You don't improve much during your daily work. Especially not with complicated issues or things that where there's a high risk. For these football players, you don't experiment during a match. It's not possible. So there's evidence that you don't learn new stuff during a match. You're learning on the training field. So you cannot do that. You need a safe-to-fail environment where you can try things out and feel the consequences and maybe try something else out and see how it goes. And have a lot of iterations in a short time, basically with no consequence for the business or clients or whatever it is. So that is quite important. So what about IT? How much do we practice? Yeah, that's up for you to decide from the companies that you come from. But simulation. What is simulation? Because simulation is a fantastic way to practice, but it's only a fantastic way to practice if it's very close to real life. And that is what simulation is all about. So simulation, we have the real life work, we have the simulation, and it's just a technique. It has to be as realistic as possible, but still it's under control, it's a controlled environment. When we do training, you could have examples, you could have games, and you could have theory. The key here is that if you want to change people's behavior, you need to make sure that they can apply it when they come back. So that is the main part. The simulations that we have invented and which we started with in 2012, it's not a simulation that is, you probably know Apollo 13 or Grab a Pizza or stuff like that. It's nothing to do with those. Those are what I call awareness simulations. They are very good for what they are intended to do for that purpose, but they are awareness simulations. you could have a fun day, or you could start a project with that, and also you could get people to think about stuff and start to think about improvements. The simulations that we have developed has nothing to do with that. They are skill-based, just like a flight simulator. So it's something that you do, and you do it many times until it becomes almost second nature. And when it becomes second nature, then you'll probably apply it in your real life work. So what is important here is this one. So it's controlled, but it's also safe to fail. And that is important for people to try stuff out. I had one training where one of the teams came and said, we have another way that we will try to troubleshoot on this. Could we try that? We think it's more effective than what you have told us. Please do, because when we run a simulation compared to traditional courses, is that it's the outcome that is interesting. So we really don't want to tell people that you need to apply this methodology. No, they are just means. The goal is to solve stuff safely, quickly, cheaply, or whatever it is. So we look at the goal of this, and then people can try it out. No, that didn't work. Let's try this instead, or this. So it's a much better way to work. What we have also done by doing this is that we can cut down theory to an absolute minimum. I just want to show you this. So instead of, we don't use PowerPoints, but this is the only theory that people get when they attend some of our troubleshooting training. This is just our methodology. There's other methodologies that can be used, but this is just to show you that this is all they get. So we have only the main key principles. That's the only thing that we give them. The rest of the theory they will experience through scenario or simulation-based training. So instead of me telling them the theory, they will experience the theory. What works, what don't work. It's another way to work, but it's extremely efficient when we are talking about this type of training. Oh. So compared to traditional training, that is very passive. We are evaluated based on our memory because we are not applied anything. So it's about memory. We are not tested in what we have been told, and the theory cannot cover everything in the world. The scenario-based training, on the other hand, learners are very active. So when we run this, maybe in 2 days, we run people through 20, that's for 3 days, but 12 to 15 exercises. People are solving scenarios in 80–90% of the time they are present at this kind of training. So it's a whole different ballgame. We don't want them just to learn the facts. We want them to learn the underlying hows and whys. Because if they understand this, they can solve everything just by applying this. So that will prepare people for these unexpected situations. And again, it's easy to transfer the learning when you come back to real life. If you can't transfer it, it's a waste of money unless you just send people on training courses, because then they don't mess anything up while they're gone, but it's an expensive way. You can just send them on holiday instead. So this is a very, very effective way of training. So how do we do it? Yeah. We don't train people in all the obvious stuff, all the simple stuff. We've seen this incident before. We know what it is. We have a workaround. We apply the workaround. We are up running again. We don't do that part. What we take is the complicated part, the stuff where we haven't seen it before, or we see a pattern, but we're not sure that we understand the patterns. So that is what we focus on. What we can do in the simulation that you cannot do anywhere else, and this is extremely effective, is that we can let people experience each other's worlds. So we can take, and we do that all the time, we can take, for example, service desk supporters, and second or third level, and we can swap them around. So they can see what is the consequences of getting something with a poor quality, or what is the consequence of getting something with a good quality. So we can swap the roles so they can experience, also for the second or third level, they can experience how tough it is, in fact, to sit in the service desk and log things so other people can understand it. Because it's very easy just to point finger and say, you are so stupid in the service desk, or the service desk, you are so stupid, you don't understand what we are writing. But putting them in a situation where they see each other's worlds and try to escalate to each other, that's extremely effective. So they understand each other, but also for the collaboration after that. So we can do that, and especially on the quality part is what quality, collaboration, and a common method. That is what we run the training in here. We have what we call swap exercises, where we have, for example, two teams. They get a major incident or an incident. These two teams, they log it. And then they escalate to each other, and they need to solve it. But they don't have the same information now. They only have the information that was logged in the ticket, basically. So they will experience the consequence of poor quality. And when you have been through 2, 3, 4, 5, 6 of these exercises, you'll see that the quality is just going up, because then they understand that poor quality makes it very difficult for other people to solve. It will also drive other teams to trial and error, because if you don't have the right information, you will end up in trial and error. You will have to make assumptions, and you will try to just do something to see what happens, and that's not a very good method, trial and error. So this is what we do. We measure on people in the simulation. So what is very unique about this is that we can measure time. So we can measure how fast are you in this, but we can also measure quality. And especially quality is something that is difficult to measure. We can measure that in the simulation. So, and that is what we call the risk part. Yes? Yes, I can. We measure what we call unnecessary actions. So whenever they are giving a scenario they need to solve, they will have to solve it by selecting some actions. If they select an action that is unnecessary, we will log it. We will tell them that you have just wasted a lot of time and money. It could be that the problem is now worse than it was when you started, so they will see the consequences of that. So we measure the quality of the output.
So that works in the simulation environment, that's why you can do it?
Yes, yes, exactly, yeah. We can practice major incident solving for teams. For these teams, for task forces, we can run them through exercises where they all have different information. So we gather a group of technicians, we feed them with different information, and also, of course, a major incident. And then we log what they are doing and tell them, solve this. And again, we are keeping track on time, on quality of this. And they will also maybe have to do some reporting to management or clients as a sidetrack during these exercises. We can go in and test the existing capability on this by applying this scenario-based or simulation-based training. And then, of course, practice real-world problem-solving, root cause analysis, and stuff like that. So I think this is the last one, just to show you, this is the effect of, and this is again the simulation part. This is not when they come back. So what you see here is that we always start with a discovery exercise. The blue one is the risk part, so you could say that is the quality. So as you can see here, when we run this for groups, we don't run it for individuals, it's always team-based. You can see that in average, they make a little above 3 unnecessary actions during this kind of exercise. So basically that is that they do a change that either doesn't do anything good or maybe worsen what they are doing right now. So that's exactly what we see in the real world, that people do actions just because I think it will work, and then they'll try the next one, and then they are in the trial and error. So this is the discovery exercise where we start them without any training at all. So this is within 15 minutes after they have started the training. There's no time on this resolution time because not all the team solves it. But you can see here after 1 scenario, 4, 8, 12 scenarios, you can see that the risk part is really decreasing. And that means that they begin to think before they act. And that is extremely important when it's complicated stuff. Yes?
The different kinds of the tasks that these groups are going through, what's the difference between the discovery task and the different scenarios?
The discovery task is, again, that they have not been trained in any method when they come in. So this is, they are starting on scratch. They probably even don't collaborate good enough on this part. And also, we have a time limit. In 25 minutes, they need to solve as much as they can. So we also put the pressure on them to a little bit force them to trial and error, just to show them this is the consequence of keeping the pressure on people when you maybe shouldn't put pressure on people. So after this, they will begin to apply also some methodology and also some collaboration and stuff like that, putting in some quality. This one is the resolution time, so you can also see that the resolution time is decreasing, even though we are bringing in incidents that covers totally different business processes and services. So they get new stuff in, it's just like in a real world where you have different system and applications. So we run it like this. We run it in an IT environment, but it can also be used as a production environment, but it's client-server based. It's based on Lego Mindstorms. But they're not playing with Lego. We are just using this as a flexible tool for this part. We have figures. This is from the simulation, of course. We have figures from Vodafone worldwide and from Siemens Healthcare in Germany, and they see an effect on their troubleshooting capability. They have some effect goals on this, with an increase of 20 to 25% on this. So, for me, this is not an option. This is the way to practice this. You cannot practice it in any other way than if you want to practice a skill. But often, much too often, when at least IT organizations are focusing on this, they focus on processes, or at least process descriptions, and service management tools. Yeah, our processes doesn't work, our incident doesn't work, our problem doesn't work, so let's buy a new tool, and then you'll pay 10 million or 5 million for a new service management tool, and you still have the same issues. And you are still just sending crap, poor quality to other teams that need that then waste a lot of time trying to clarify what it's all about. We had an interesting analysis. It's 2 months ago in a major company in Denmark, where we went into all the second and third level teams. We asked them to open your queue of your incidents. Have a look at your queue. How many of these incidents, just from the headline, do you understand what it's about? It was below 50% of the incidents in the queue that the technicians understood what was in the record. When they opened it, in many of the cases, they didn't become any wiser. A lot of the stuff were escalated wrongly to the wrongly team, but the people who has collected the data has not collected the correct data, or at least did not try to get some facts in. So we see that they escalate to the wrong team based on poor quality. And what will happen if you have 10 incidents in your queue? You understand 10 of them, and you don't understand the last 10. Which one do you think they start solving? Yeah? They will, it's only natural. We'll start solving what we can identify, what seems like, yeah, I understand that. Is that a good way to prioritize? No. Could be some of the other incidents that were much more critical in this, but they don't start there, because you will always start with what you is familiar with and what you think is good. Yeah. And sorry, the tool will not help you, yeah. And about the knowledge management, we have a lot of companies who are working with knowledge management. And we are categorizing stuff in incidents, problem changes, a lot of categorization. And categorization is for old people. Old people like me, Just look at young people today. When they go in and Google something, if I write SAP problem, I get 4 billion hits on this. But if I write that when I open this module, I get this error message or something like that, then most likely I get the correct hit in one of the top issues. So putting in quality stuff into your incidents and problems will make you able to find them again. But if you don't put any quality in, if it's just a network problem, SAP problem, or whatever you put in, it's just crap. It's just a waste of time. So also for the knowledge management part, we need to work on quality. Quality is key, and I think we have forgotten quality on this because it's a little bit more tough. It's much more easy just to buy a new tool, but yeah, it won't help.